Oh, okay, Sandia. All right, very good. But you saw the then that okay, very good. But now the course content. I hope you like the course content, Sandia. Excellent, excellent, excellent. Um, all right, all right. So let me give you a moment to copy this example down. We are doing section 5.6, integration by parts, and I want to do another example with you. All right, so let me give you a moment to copy this example down. Okay, so for this problem here, this is an interesting problem because well, first of all, let me write down the integration by parts formula. Let me just write it down here for you. The integral of u dv equals u times v minus the integral of v du. Okay, there's the integration by parts formula. And this problem here, because you have e to the square root of x power, and just doing integration by parts directly will not work here. Okay, what makes this problem complicated? What makes this finding the antiderivative of e to the square root of x complicated?
The square root.
That's right, Tosh, the square root of x. So what we're going to do is we're going to make a substitution first. We're going to let u equal the square root of x. In other words, we're not going to do integration by parts right away. Okay, that we're going to do a substitution, and then we're going to do integration by parts. Okay, I mean, so far the problems you've seen are pretty much either you do a substitution or you do an integration by parts, although I've shown you about doing a substitution followed by integration by parts. But this problem here, you will not be able to get it without easily without a substitution. So, okay, let's go to the next page. We're going to let u equal the square root of x, which is x to the half power. Okay, well, in that case, du dx is, oh, okay, so let me just see here. Hold on. So e to the square root of x is the same as e to the uth power with this substitution here. But now the question is, what is dx going to become? And what about the two limits? They also have to be converted. Well, so since u equals x to the half power, du dx is equal to 1/2 times x to the negative half power. But again, what I want is I want dx written in terms of the variable u. So what I'm going to do is I'm going to multiply both sides of this equation by dx. And then, of course, the dx's simplify. And so du is 1/2 times x to the negative half dx. And, you know, what I want to do, remember, is I want to get dx by itself. I want to get dx by itself. So what I'm going to do is I'm going to multiply. You know, I have an x to the negative half here, right? I have an x to the negative half here. I don't want that x to the negative half there. I want there to be a 1 there. So I'm going to multiply both sides of this equation by x to the half power. Well, x to the negative half times x to the positive half is x to the negative half plus a half power, which is x to the 0, which is 1. Okay, and so you see that's going to give me then on the right hand side, I'm going to get then a 1 dx, right? I'm going to get a 1 dx. But I still have a half in front. And what I can do now is I can multiply both sides of the equation by 2. And so then dx, that 2 times a half is 1. That's going to give me, you know, 1 dx equals 2u du. And so now I know what dx is. Dx is 2u du. The u limits 1 and 4 naturally will become 1 and 2 because, I'm sorry, the x limits of 1 and 2 will be converted to u limits of square root of 1 and square root of 4. I don't know why that all got erased there, but that's fine. It's there in the recording. And so here we are. Here we are. And so now and naturally, I'm going to bring that 2 out in front. So now we have an integral that certainly looks easier to work with. Okay. Are there any questions up to this step here? We're not done yet, but are there any questions? Please let me know. All right. Well, so here we are. Here we are. For this integral now, what comes next? How are we going to find the antiderivative of u times e to the u? Are we going to do substitution or are we going to do integration by parts? What's the right process?
Integration by part.
That's right, Ange. Integration by parts. Okay, integration by parts. And so I'll go to the next page and show you the integration by parts. Are there any questions? Okay. So here's our integral. Now the integral here is an integral with respect to u. My normal integration by parts formula is integral of u dv equals uv minus the integral of v du. But because I have the variable u in the integral, and I don't want to get confused, let me adjust the integration by parts formula to integral of w dv. Instead of integral of u dv, I'll do integral of w dv. Well, if I, follow the pattern here, integral of w dv would equal wv minus the integral of v dw. So everywhere in the formula above where I had a u or a du, I replaced it with a w or a dw. And so now, okay, I'm gonna work this problem out. Well, if we let w equals u and dv equals e to the u du, that's the right assignment to do. Okay, if you were to do, like, if you were to let dv equal u du, then you would end up getting a more complicated integral resulting when you do integration by parts. How many had that happen, by the way? How many had that happen? Maybe when you did your had that experience with integration by parts. Okay, Taj has. So what I'm trying to say, class, okay, D'Angelo, what I'm trying to say is, let's say that you decide, okay, I'm gonna let W equal e to the u, and I'm gonna let dv equal u du. Hold on, now one moment. Yeah, if you do that, then dw is equal to e to the u du, and v would equal u squared over 2. That's the antiderivative of u. And so the integral would be then e to the u times u squared over 2, evaluated from 1 to 2, minus the integral of u squared over 2. I'm just following this formula here, u squared over 2, times e to the u du, right? So what happens is this, oh yeah, and the limit, of course, when you do integration by parts, the limits stay the same, right? They don't change. But you see here, look at this resulting integral here that you have to integrate, the integral of u squared over 2 times e to the u du. Well, was that more complicated or less complicated than the integral you started with? Did we get a more complicated integral here, or a less complicated integral than the integral we started with?
It's more complicated than what we started with.
More complicated. That's right. So that's a dead end road. Then doing it that way. That's not gonna that's gonna not work. So that's then you don't want to say then w equals e to the u. Try letting w equal u, and dv being equal to e to the u du. Okay, so if you do that, so integral of w dv, okay, I'm sorry, w, right, that's the left hand side here, right, integral of w dv. So if you do that, then you're gonna get a nice result here, because this so what is this? This is wv. The integration by parts is wv minus the integral of v dw, and that's this here, and this integral here, the integral of e to the u du, you can do. So that tells you you're going the right way. Are there any questions to this step here? Okay. All right, so you just work it out. You just work it out. Now put in your, the antiderivative of e to the u is e to the u. And you just put your limits in, and you get there. You get 2e squared. And that's the exact value for that definite integral. Are there any questions? All right. All right. Well, then the final answer then, if there's no questions, hopefully everybody's had a chance to copy okay. I try to make sure I pace myself well. How did I get to 2, Mario? All right, the two comes from like this 2 here is that 2. Oh, u equals, okay. How did I get that? Yeah, if I go back to the previous page, when I did the substitution, u was equal to the square root of x. So the 4, that x limit, becomes then, as a u limit, would be the square root of 4, and that gets you 2. And the 1, that x limit, would be the square root of 1. All right, very good. Are there any other good questions? All right, well, then, of course, then, we can say then that the integral of e to the square root of x dx from 1 to 4 equals 2 times e squared. So e to the square root of x is a positive function from 1 to 4. The area between that function, e to the square root of x, and the x-axis from x equals 1 to x equals 4 would be 2 times e squared.
Professor?
Yes, Jason.
Could you go back one slide, please? Just
Sure.
Hold on a second.
Sure.
Okay, thank you.
All right, you're welcome. So let's go ahead. I want to do just go to the whiteboard for a moment. And let's say, let me just ask you, I'm not going to work this problem completely out, but let's say that your integral was the integral of the sine of the log of x dx. Okay, and let's say, this problem, again, it's a one where you're going to have to make a substitution first. what would the substitution be that you would recommend?
U equal ln f x.
That's right. That's right, Sandia. That's right. And u equals the log of x. If you do that, well, we got to be a little careful here now. So we have here then the sine of the log of x. That's correct, Sandia. There's really that log of x as the angle of the sine is complicated. So the sine of u is a lot easier to work with. But we have to then, okay, what about dx? What's that going to be? What's that going to be? Well, okay, so we have to find out what dx equals. And u equals the log of x is what we have to work with. So I need to get a dx in there somehow. Let me just say, okay, well, du dx. Okay, hold on. Right, that equals 1 over x. So then du equals 1 over x dx. Okay. Got to be a little bit careful here. Du equals 1 over x dx. There's the d. Oh, I'm sorry. Thank you. This should be a dx here. Yeah. Du equals 1 over x dx. So that means x times du, you know, if I multiply by
X.
Yeah, by x both sides. Let me just put an x here. Whoops, hold on. Over x dx. Multiply by x both sides. I'm going to get that x du equals dx. But now the question is, what is, you know, what is this x here? Well, remember, u was equal to log of x. And, yep.
Yeah. So u equal, so x should be equal to exponential of u.
That's exactly right. E to the u would be e to the log of x. Okay. And so that means e to the u equals x. And so now we know that dx is e to the u. Okay, so sometimes it takes a little thought, but now our new integral is the sine of u times e to the u du. Right? That's our new integral. Okay, are there any questions on that? Well, what I did, Xavier's asking, how did I get the exponential? So yeah, well it's based on what I'm looking for. I need to find what x is in terms of u. So all I have to work with is u equals e to the log of x power. If I exponentiate both sides, e to the log of x, they're, as Sandia says, they're inverse functions. That gives you x. So x equals e to the u. All right, and now integrate by parts. Integrate by parts on this one, okay? Now with this integral, you got to do integration by parts, and I'll let you, I'll let you, if you want, finish that on your own. I'm just, wanted you to see there are different kinds of problems where you have to make substitutions and then, then integration by parts. And I just wanted to have you see another one, so you can finish that. Are there any questions before I stop the recording? Okay.